Hey guys, here's part 2 of our graphing video. So we're graphing day 2 with phase shifts and vertical shifts. So we're still looking at our main function here. Remember, A is our amplitude, or it's our vertical stretch or shift, or our reflection. So A tells us a lot about how our graph is going to look. B affects the period of the graph, 2 pi over B for the main 4 and pi over B for tangent and cotangent. And then we want to make sure that our B is factored out of our horizontal shift, which we call a phase shift. And if it is, it's just equal to C. If the B is not factored out, that's when you have to take C divided by B to get your phase shift. So if it's factored out in front of a parenthesis, you're good. If not, you have to divide C by B. And then the number at the end is your vertical shift, up or down. All right, so our general form for this one would be A tangent B x minus C plus D. So a couple things we have to start is an amplitude. We don't have an amplitude because it's tangent, but we do have an A value that's 2. 2 is going to make that a vertical stretch. Vertical stretch there. And then we have a period for tangent is pi over B, and our B value in this example is 3. So our period is going to be pi over 3. And then we have our x scale. So we're going to be taking our pi over 3 and breaking it into equal fourths. And so that means we're going to be counting by pi over 12s. Pi over 12s for this one. And then we are going to be shifting it, but we have to factor out our B here to find our correct shift, or take our C divided by B. So I'm going to rewrite this. I'm going to factor out the B. So taking out the 3 is going to give me an x minus pi over 3. And then we have no vertical shift. So that means our phase shift, since it's minus pi over 3, it's going to be the opposite. We're going to be shifting it to the right pi over 3. And then we have no vertical shift, or not applicable, or is vertical shift of 0. All right, so let's start by just filling in some x-axis values. So we have an x scale of pi over 12. So we're going to be counting by pi over 12s. So 1 pi over 12, and then we're going to have a 2 pi over 12. I wrote that down here because I know it's going to simplify to pi over 6. And then 3 pi over 12 is going to be divisible by 3. It's going to simplify to 1 pi over 4. 4 pi over 12 is going to simplify to pi over 3. And then we're going to have 5 pi over 12. 6 pi over 12 is going to simplify to just pi over 2. And then 7 pi over 12. And because we're graphing tangent, we're actually going to want the couple negative spots over here too. Negative pi over 12. Well, actually, we're going to be shifting it to the right pi over 3, so maybe I'll wait on putting some negatives in here because we're shifting it so far to the right. So now I'll do my phase shift at pi over 3. So we're going to have a phase shift right here, and then it's not vertically shifted at all. So remember, that means we're going to treat this point right there at pi over 3 and 0 as my origin, 0, 0. So I'm going to graph the rest of my points from that point. So my 0 point on like my table is going to be pi over 3. Now I need to figure out your y coordinates. So remember, you're going to use your unit circle to graph or to figure out your y values for your table. And tangent is going to be the sine over cosine. So tangent is y over x. And so when you're thinking about that on your unit circle, if you start at the first point is 1, 0, and then 0, 1, and then negative 1, 0, and 0, negative 1. Tangent is y over x. which means that anytime our x coordinate is 0, tangent is going to be undefined. So tangent is going to be undefined right here and right here, and you're going to have asymptotes there. So typically when we graph tangent, we are going to graph it from the negative y-axis to the positive y-axis, and we're going to graph it like this, which means in my table, I'm actually going to put my pi over 3 spot at my 0 spot. So, and then you're going to use the 45-degree angles in each of those quadrants. And so you're going to start with an undefined value, and then you're going to have your pi over 3, your 0 spot right there, and then you're going to end with an undefined value. So you're going to go from this one and then back around. And then you're going to stop at the 45-degree ones, because tangent of 45 degrees is 1. So we use that because it works out nicely. So in our first output, it's going to be undefined because -1 over 0, undefined. And then we're going to go to our next point, and it's in the fourth quadrant, so it's going to be -1. So our next output is going to be -1. And then we are back at the x-axis, and tangent is going to be 0 over 1, so 0. And then we go up to our positive 45-degree angle, and tangent's going to be 1. And then we make it back to our positive y-axis, and tangent's going to be undefined there. Now for these to match up with our values from our x, 2 to the right, pi over 3, then it was 5 pi over 12, and then it was pi over 2, and then 2 to the left, this was pi over 4 and pi over 6. And so you can start by putting those asymptotes at pi over 6, and then pi over 2 was your other asymptote. And then our a value is 2, so we actually need a 2 times y column here. So we are still undefined here, but it's going to be -2, 0, +2, and then undefined again. So when we're graphing this, we're graphing from my asymptote, it's undefined. My next point, pi over 4, we're going down to, so -2. And then at pi over 3 is my 0. And then at 5 pi over 12, I'm going up to, my a value is 2. And then I can draw my curve nicely there. So, and then we could repeat this if we wanted. So we would have, if we have a positive pi over 6, and then we'd go back 2, and then go back 2 more, we'd have a asymptote at negative pi over 6 as well. And then it would be -2, 0, +2, tangent's an increasing function. And so we could graph another cycle of it like that. So that would be tangent. Now, if you look at this carefully, you might notice that it's actually the same as the regular tangent without the phase shift. And that's because the phase shift was the same as the period. And so we ended up shifting this over 1 complete pi over 3 value, in which case it becomes the same as if we didn't shift it. So kind of interesting there. All right. Hopefully that made sense. I know it's kind of a lot and it's a video, so I'm doing the best that I can here with explaining it. All right, so now let's do a secant, and then we're going to do a cosecant. So for secant, if it was cosine, we'd have an amplitude, but it's secant, so we just have an a value of 4. That's going to tell me it's a vertical stretch. But my cosine curve would have an amplitude of 4. Period for these are going to be 2 pi over b, and your b value is going to be 2. So 2 pi over 2 is going to be a period of pi. And then if you take pi and cut it into equal fourths, you're going to be counting by pi over 4s. And then our minus, our c is going to be negative pi over 4, and that's going to be our phase shift. So we're going to shift it left pi over 4. And then our plus d is there, so our vertical shift is going to be down 3. So I'm going to start by using my x scale factor and filling in some x values on my x-axis. And I have to go a little bit negative since I have a phase shift to the left. So I'm counting by pi over 4. So 1 pi over 4, 2 pi over 4, which would be pi over 2, 3 pi over 4, 4 pi over 4 would be pi, 5 pi over 4, 6 pi over 4 would be 3 pi over 2, 7 pi over 4, and then backwards negative pi over 4 and negative pi over 2. And remember, you can pause this and fill that in. And then we're shifting it down 3. So we got -1, -2, -3, and we have an amplitude of 4. So I'm going to actually have to go down further here because I'm going to have to go down 4 from my -3 point and -7. So putting in our shift then, we're going to have a vertical shift of our phase shift of negative pi over 4. So that's right here. And then a vertical shift of down 3. Trying to draw straight lines. There we go. I like notability. There we go. Okay, and then we're going to use this point right here as our new origin point where those vertical and horizontal shifts intersect. So we're going to graph from there. Now, the easiest way to graph secant is to graph cosine first. So cosine, if I look at my y values for cosine, I can use my unit circle again. Remember, cosine is the x coordinates on the unit circle. So 1, 0, 0, 1, -1, 0, 0, -1. Cosine is the x coordinates. So we're starting at 1, 0, -1, 0 because we start at positive x-axis and go counterclockwise. So cosine's pattern is 1, 0, -1, 0, back to 1 in a full, usually 2 pi. This time we have a period of just pi. So it's typically a period of 2 pi here, but this time it's just pi, which means this is pi over 2, this is pi over 4, this is 3 pi over 4, so that I'm making one full rotation in pi units instead of 2 pi units. And then I want to graph from my shift, and I actually have an amplitude of 4, a value of 4, so I have to do 4y here. And so I'm multiplying my middle numbers here by 4. It's going to be 4, 0, -4, 0, 4. So I'm going to graph from my 0, 0 point, and I'm just going to do this as just as a dashed line because this is actually my cosine graph. So this is not my secant graph yet. So graphing from my first point up 4, 1, 2, 3, 4 is going to leave me at +1 there. And then at my next point, which would be at 0 here, and then 0. And then at my next point would be pi over 4, and then I'm going to go down 4, which is going to be at -7. And then at pi over 2, I'm going to go back up to 4. So if you wanted to fill in the x's, I am graphing at negative pi over 4 is my first one. Then it was 0. Then I'm at pi over 4. Then pi over 2. Then 3 pi over 4. And from negative pi over 4 to positive 3 pi over 4 is a total distance of pi. So that would be 1 period. So then at 3 pi over 4, I should be back up 4. And when I'm back up 4, that's 1, 2, 3, 4 from this line. So that's why I'm actually at 1. So this is one cycle of cosine. And then I could continue that pattern. I'd be back to 0, then back to -7, back to my 0 line, back to here. And I could continue that. Now secant is the reciprocal of cosine. And if you have a secant value equal to 0, or a cosine value equal to 0, then secant is going to be undefined. So you're going to have an asymptote right here along my x-axis. You're going to have another asymptote at pi over 2 because these are where my cosine value is equal to 0. These points that I'm highlighting, those are going to be your asymptotes of your inverse. So then I have an asymptote at pi and an asymptote at 3 pi over 2. And then if you remember what I was talking about with reciprocals, if you have the original function here is decreasing, then the inverse will be increasing along that same interval. And they're going to be equal here because if cosine was equal to 1 or 4, if cosine was equal to 1, then the reciprocal of 1 is still 1, and 1 times 4 is still 4. So they're going to be equal at that point. And then they're going to have the reciprocal shape, so it's going to be increasing instead of decreasing. And then on this interval, it decreases and then increases, and so it's going to be reciprocated, increasing, then decreasing, and then equal at this point. And this interval, it's going to be equal at this point, and then decreasing, and then increasing, and then equal at this point, and then decreasing, increasing, then decreasing, and hopefully you get the point by now. And so if I got rid of everything and you only saw the black curves, that's my secant graph. I just got a lot going on there, but those black curves are my official graph. All right. Feel free to pause it and go back at any time. One more. All right. So we have a cosecant. We have a -2 out front that doesn't have an amplitude. A of -2 is going to tell you two things. First of all, the absolute value of -2 is greater than 1, so it's going to be a vertical stretch. And then the negative is going to be a reflection, so it's going to be reflected. So sine curve usually looks like this, and it's going to be reflected like, like this, and then it's going to be the inverse of that. So we got a lot going on this one. And then our period is going to be 2 pi over b because it's a reciprocal of sine, so it takes 2 pi to go around the circle before it starts repeating. And your b value is 3 here, so it's going to be a period of 2 pi over 3, which means that if you take 2 pi over 3 and cut it into equal fourths, it's going to be 2 pi over 12 or pi over 6 for what you're counting by on your x-axis. And then you have your x minus c is going to be your phase shift, which means it's going to be negative pi over 3. So you're going to be shifting it left pi over 3 radians. And then you have your plus d, so your vertical shift is going to be down 4. All right. I'm going to start with my x scale and draw out some numbers along the x-axis. So counting by pi over 6. So 1 pi over 6, 2 pi over 6 is going to be pi over 3. 3 pi, so 2 pi over 6, you can see how that reduces. 3 pi over 6 is going to be pi over 2. 4 pi over 6 is going to be 2 pi over 3. 5 pi over 6 won't reduce. 6 pi over 6 is going to be pi. I think that'll be enough. I got to go to the left a couple times too. So negative pi over 6 and negative pi over 3. So that was my phase shift, was negative pi over 3. So I think I'm going to put that on here. Negative pi over 3. So I'm shifting it left. And then I had to shift it down 4. I'm going to have to get rid of this, and I'm probably going to have to extend this a little bit. Negative 1, negative 2, negative 3, negative 4. And then I had an a of 2, so I'm going to have to go down to at least negative 6 for this one. And then I'm going to shift my whole graph down 4. And then I'm going to graph from the intersection of those shift points and treat this like my new 0, 0 point. Right here. So that's 0, 0 now. And I want to graph, my line got a little crooked, there we go. I want to graph cosecant, which means I'm going to graph sine and then do the reciprocal of it. So I'm going to graph sine like I had a negative a value, a negative 2a. So my sine is my y coordinates. So 1, 0, 0, 1, negative 1, 0, 0, negative 1, And then my y coordinates, starting at the positive x-axis and going this way. Typically we end at 2 pi. This time we're ending at 2 pi over 3, but it's been shifted, so kind of all over the place. But if we want to just see our pattern for our y values, it's going to be 0, starting at 0, then 1, then 0, -1, 0. So that's my, oh, I got to get to class. Okay, that's my sine pattern. And then I have a -2a value, so I have to multiply all these y values by -2. And then I'm going to graph, this is going to be my sine curve, and I'm going to start at -pi over 3, and then -pi over 6, because that's my vertical or my horizontal shift, then 0, then pi over 6, then pi over 3. So I'm going to start at -pi over 3, and I'm going to be at 0. So 0, 0 is right there. Then -pi over 6 and down 2. Then 0 and 0. Then positive pi over 6 up 2. Then pi over 3 at 0. So there is my one cycle of sine. And then I could continue that pattern. So -1, 0, 1, 0, and it would keep going. Okay? Then sine is going to, or cosecant is going to be undefined anytime sine was equal to 0, which is all these red spots that I'm putting on here where we cross that 0 line, that shift line. So you're going to have an asymptote at -pi over 3. You're going to have an asymptote at 0, at pi over 3, at 2 pi over 3, and at pi. And then your function is going to be the reciprocal of the sine curve. And so it's going to be equal at the top, the max or min points, and then it's going to turn in the reverse direction as the original curve. So equal and then turn reversed, equal and then reversed, equal and then reversed. And that is our cosecant that has been shifted and moved around and all sorts of things. All right, I have to get to class. Hopefully that was helpful. Thanks for watching.